Hey, we're going to go ahead and take a look at section 2 of chapter 10. We're going to actually be looking at some of the stuff that you see over here on the graph. We're going to be looking to see where we would say have a low spot, which we would call a relative minimum. We would also be looking at where we have a relatively high spot, which we would call our maximums. Now, we actually have two different types of maximums here, a globe or absolute maximum, which would be the highest of the whole graph, or a relative maximum. For the most part, if you would just list them both as relative, I'd be fine with that. Also, we're going to be looking at things like where we're crossing the x-axis, which we would know would be our zeros, or also where you're crossing the y-axis, which is your y-intercept. And then also looking at the end behavior that we looked at yesterday. So those are some of the things that we're going to be looking at. So just as an FYI. Now remember, if it is odd, it's a disco. If it's even, it's a touchdown. And remember, when you're looking at end behavior, you need to write out this whole thing, and all you do is figure out and adjust what goes in front of the infinities. Depending upon if it goes up, then it's a positive infinity. If it goes down, then it's a negative infinity, and that's for your end behavior. So if we just look at this graph before we do one of our problems, we're going to look at the zeros. Well, the zeros would be where you cross here, and for the most part, we're going to try to go to the nearest tenth. So we would say this one right here would be about negative 1.7. And then we would say this one over here would probably be about a negative 2.2. Then we need to write down our maximum. We have a maximum here, which we could write down, which would be at negative 2 and looks to be at a height of 2. And then we're going to write down our second maximum, which would be here. And well, that appears to be about 0.4 over, and maybe at a height of like negative 1.2 or something like that. We'd also have to indicate our minimum, which would be down here, which is at 1 to the left and 7 down. We then need to go ahead and write our y-intercept, which is here at negative 2. And then we got to look at our end behavior. So we can see from our graph that we go down in each direction. So remember, this right here means as you go far to the right on your graph, and as you go to the right, you see that you go down, so you put a negative in front of your infinity. Also, we can see that means x going far to the left in your graph, and you can see looking at your graph, it also goes down, so you put a negative infinity there. So that's just kind of a quick overview. So now all we're going to do is do all that same information with this function right here. So you want to go to Desmos and type that in. So pause the video and type that in. So looking at Desmos, we would get this here. Now, remember, you can hit the gear sign and then hit the table, and you can go ahead and expand your table if you needed. And I'm going to expand it a little bit so that it ends up covering where our graph goes. Now, you can also use Desmos, and by the way, you need to have your table so that you can accurately plot these points. So when we go back here, you would get something that looks like this. Now, this first part, the number of zeros, that's how many times you cross the x-axis, which it only crossed once. And it crosses about right there. Now, looking at our scale, we know that this is 3. So if this is 2, it crosses at about 2.7. And when you're looking at Desmos, you can see, if you touch right here, that if you go to the nearest tenth, it would be 2.7. Then you'd want to look at your minimum. That's the lowest point, which you would know would be right here. Well, looking back at decimals, you can see that that point would be right there, and you could write the coordinates down. When you are looking at your maximum, which would be right here, we can see it would be this. And then looking at decimals, you can see it would be that. Then the end behavior. So remember that this means as you go far to the left on your graph, does it go up or go down? And you can see as you go to the left, it goes down forever. So then it's going to have this negative in front. Remember, this means as you go far to the right on your graph, because x goes left and right and going towards the big positives, you can see that it goes up forever, and so that's why we have a big plus sign here. So at this point, pause the video, try to do this one on decimals, and then we'll talk through this. So now that you paused the video and did this one on decimals, we can talk through it. So we'll go back here to decimals. And you can see what we have. We have our table and we have our chart. So you can find your maximum up here, you can find your minimum here, your minimum here, you can find where you're crossing, you can find all of those. So if we go on to our next slide, you can plot your points by using your table feature in decimals that we just talked about a little bit ago. Now, the number of zeros is how many times you cross. Well, you can see you cross your x-axis twice, once here and once here. Looking at decimals, you can see the two spots of where it crosses, so you could write those down to the nearest tenth, and that's what we would have here. Your minimums, looking at decimals, would be this low spot up here and this low spot down here, which on your graph right here would be this one, and then you can write those spots down. Now, your maximum, looking at decimals, is this spot up here, which you can see is this, and you can write that down. And then, because we are even exponent with a positive in front, you know it's a normal touchdown. We go up as we go to the right, and so this means as you go to the right, we go up, so that's why this is positive. Also, as you go to the left, we go up, and so this means as you go to the left, we go up, so that's positive. And so that's what we're looking at for these problems.